Every planet you've ever heard of orbits a star. It has a sun, a sky, a year. But scattered across our galaxy, there are planets with none of that. No sun, no daylight, no seasons, drifting alone through interstellar darkness. They're called rogue planets. And here's the number that should stop you. There may be more of them than there are stars in the Milky Way. Trillions of worlds wandering in the dark. This January, for the first time in history, astronomers caught one and weighed it. So what did they find? And how does a planet end up with no star at all? Start with how strange this is. Planets form around stars. This is the whole textbook picture. A young star wraps itself in a disk of gas and dust, and inside that disk, worlds grow. Every planet is born into a family, bound to its sun by gravity. A planet without a star should not be wandering out there. And yet, since the year 2000, astronomers have kept finding evidence of exactly that. Worlds adrift between the stars, belonging to nothing. A few may have formed alone, condensing straight out of a collapsing cloud like failed stars. But as we'll see, most of them seem to have a darker origin story. Think about what that means on the surface of one. No sunrise, ever. The sky is permanent night, lit only by the same distant stars we see. Except there's no morning coming. A frozen world sailing through emptiness at tens of kilometers a second, for billions of years. That's not science fiction. Our galaxy appears to be full of them. Here's the obvious problem. Planets do not shine. Everything we know about finding planets depends on their star. We watch the star wobble, or we watch it dim as the planet crosses in front. A rogue planet has no star to give it away. It's a dark object in a dark galaxy. So how do you find something that emits almost no light at all? You use the one thing it cannot hide: gravity. Mass bends space itself. That's Einstein. So when a rogue planet drifts, by pure chance, in front of a distant background star, its gravity acts like a lens. For a few hours, that star appears to flare brighter, then settles back as the invisible wanderer moves on. The planet never appears. Only its shadow in space-time does. Astronomers call it microlensing, and it's less like photographing a planet and more like noticing a fingerprint on the light. For 25 years, that trick had a catch. A microlensing flare tells you something passed, but not how far away it is. And without the distance, you cannot pin down the mass. Every rogue planet ever found lived inside that uncertainty. Astronomers could not even rule out that some of them were not planets at all, but failed stars called brown dwarfs. The whole population was a census of ghosts. That is what changed this January. A team led by Subo at Peking University caught a microlensing event, and this time they watched it from two places at once: telescopes on the ground and the Gaia spacecraft out in space. The flare arrived at slightly different moments in each. That tiny timing offset, a parallax, the same trick your two eyes use to judge depth, broke the degeneracy. For the first time ever, a rogue planet had both a distance and a mass. It sits about 9,800 light-years away, towards the center of the galaxy, and it weighs about as much as Saturn. That number matters. It's far too light to be a failed star, and squarely in the range of a true planet. The ghost had finally been pinned down, and it was one of us, a planet. So where do they come from? A Saturn-mass world is too small to have formed alone the way stars do. It had to be born the ordinary way, in a disk around a young star. Which means it did not start rogue, it was made rogue, and the mechanism is planetary violence. Young planetary systems are not the tidy clockwork we live in today. They are crowded, unstable places. Giant planets migrate, orbits cross, and when two massive worlds swing too close, gravity turns into a slingshot. One planet gets flung inward, or into a wilder orbit. The other can be thrown out entirely, ejected from its own system, exiled at escape velocity, never to return. The researchers behind the January discovery concluded exactly this. Violent dynamical processes shape this population. Every rogue planet drifting out there is most likely a world that was thrown away by its own family. And before we feel superior about our own solar system, the same models say systems like ours routinely ejected planets in their youth. There's a real chance the sun once had another giant world and that it's out there right now, nameless in the dark between the stars. If you've seen our Planet 9 video, you'll recognize the mirror image. We're hunting for a planet we might still have, and somewhere out there may be one that we've lost. Now, scale that up. Because one confirmed wanderer is just the beginning. Microlensing surveys keep detecting these brief, planet-sized flares, and the statistics behind them point somewhere staggering. Free-floating planets appear to be everywhere. Some estimates suggest they outnumber the stars. The Euclid Space Telescope recently stared into a single young star cluster, Sigma Orionis, and found newborn free-floating worlds down to just a few times the mass of Jupiter. Planets barely 3 million years old, still glowing with the heat of their own formation, and already alone. The galaxy is not just making rogue planets by accident. It's making them constantly, as a matter of routine. The honest question everyone asks next is, could one drift through our solar system? In principle, yes, nothing forbids it. In practice, space is so vast and these worlds so sparse that a close encounter is extraordinarily unlikely on human timescales. The unsettling part is not a collision. The unsettling part is the census. The galaxy we thought we knew, stars with planets around them, may be outnumbered by worlds no telescope has ever seen. A whole silent population between the stars. And this is why the January measurement matters more than one planet. It proved the method. NASA's Nancy Grace Roman Space Telescope, launching in the next couple of years, will scan the sky vastly faster than Hubble and is expected to find these microlensing flares not one at a time, but by the hundreds and thousands, turning a handful of ghost detections into real census of the invisible galaxy. Within a decade, we may know whether starless worlds truly outnumber suns. Think about what that would mean. The default planet in our galaxy might not be a world like Earth, warm in the light of a star. It might be a frozen wanderer in the dark, and everything we call normal might be the exception. So here's where this leaves us. The galaxy is full of planets that belong to nothing. Born in families, thrown out by their own giants. Sailing through permanent night in numbers that may exceed the stars themselves. We finally weighed one. The instruments that will count the rest are already being built. And somewhere out there, quite possibly, is a world the sun discarded before the Earth was even finished forming. This channel is about exactly these moments, when the universe proves stranger and fuller than the picture in the textbook. If you want to be here when the census comes in, subscribe and stick around. Until next time, clear skies.